Okay, so let's have a look at 2024 Higher Level Maths Leaving Cert Paper 2, Question 1. A group of 22 students were tested to see how far in meters each of them could swim without stopping for a rest. The results of the testing are shown in the ordered stem and leaf plot below. 4 of the entries have been replaced with the letters A, B, C, and D. Okay, so the first question is, let's see, the mode of the data is 34 meters. Use this to write down the value of A. Okay, so we can see here that we have A here, and we have two 34s there. So I'm assuming A is 4. Let's just see, is there anything else that might help? Well, we have two 57s, and I think that's it. So it must be 4. So our first answer here is A is equal to 4. Okay, second one then. The range of the data is 49 meters. Use this to find the value of B and C. Let's have a look at the possibilities here. So the range of the data is 49. So the range is the maximum minus the minimum. So what can the maximum be? The maximum can be 68. This is an ordered stem and leaf plot, so it must be 68 or greater, 68 or 69. So it's going to be 68 minus and 69 minus something, and that's it from the top end anyway. Now it could be 68 minus what? Well, if we look up here, it could be 22. So we could subtract 22, and we could subtract 21, so it could be 68 minus 21, and actually it could be 68 minus 20 as well, so it could be 68 minus 20. So there are 3 possibilities if we take 68 as our highest number. So let's have a look. It could be 69 as well, so we could take 69 as I said here, and that could be again minus 22. It could be 69 minus 21. It could be 69 minus 20. And I think they're all the possibilities. I think there are just 6 possibilities here. So let's work all of these out. So we were told that the range is 49 meters. So the only way we can get 49 meters is to take 69 as the highest value and 20 as the lowest value. So therefore, B must be equal to 0 and C must be equal to 9. Okay, so that's it for that part of the question. Let's have a look at part 3. The median of the data is 43.5 meters. Use this to find the value of D. So 43.5, so this is not one of the data, so it's between 2 data points here. So 22 is an even number, so if you divide 22 by 2 you get 11. So it's going to be the 11th and 12th number that we have to add and divide by 2. So it's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So it's going to be 40 plus D. This is 40, and we're going to add a unit here. These are units out here, so it's going to be 40 plus D. And then we're going to add 45, then divide by 2, and that should give us our median. So let's do that. So it's going to be 40 plus D. That's the first number. We're going to add 45, which is the next number. We've got to add both of those, divide by 2, and our answer is the median, which they tell us is 43.5. Okay, so we just got to solve for D then. So let's see, multiply across by 2 anyway. So we've got 40 plus D plus 45 is equal to 87. Next thing we've got to do is just work out what D is. So I'm going to take 87, subtract 45, take 87, subtract 40, and you'll get D is equal to 2. Okay, let's have a look at this one. Oh yeah, I've done this one already because it just took a little bit of explaining. Let's see. 7 of the 22 students took swimming lessons. They were retested after the lessons to see how far they could swim without stopping. The table and graph below shows the results of the initial test and retest for these students. These are the original distances that they could swim, so 22 meters up to 61 meters. So after they did their swimming lessons, they were tested again, and you can see the person who swam 22 meters could now swim 25. The person who originally could swim 61 improved a lot. They could swim 350 meters without stopping. So really what's happening here is the more the students could swim originally, the more they improved. There's a huge gap between these two. There's a very small gap between these two here. So if they couldn't swim too far originally, they still couldn't swim too far after the lessons, but they did improve slightly, and it does increase. So what I'm saying here is that there is a strong positive correlation between the distance in the initial test and the distance in the retest. So we could, draw a line up through here maybe, something like that, or even like that. But anyway, there's a strong positive correlation is what I'm saying. Although it does kind of look as if it may not be linear, but let's assume that it is linear and that there is a strong positive correlation. What I'm saying is that students who could swim further in the original test improved more, relatively speaking, in the retest. Example, so I give an example as well. I took the slowest and the fastest swimmer. The slowest swimmer improved by 3/22. 3 is the difference. They originally could swim 22, they improved up to 25, that's a difference of 3 meters. So it's 3 divided by the original distance, which is 22 times 100. So they improved by 13.6%. Whereas the fastest swimmer they increased their distance by the difference between these two, which is 289. Divided by the original distance, 61 times 100, they improved by 474% here. So what I'm saying here is that the further the student could swim originally, the more they improved. So that's really it for that one, okay? Let's have a look at C. Okay, so this was just a case of working out the correlation coefficient. So this is a case of just knowing what to do on your calculator. You just stick both sets of data into your calculator in 2 columns and your calculator will work out OR for you. Okay, so look, that's it for the first question.